In today's lesson, you will learn how to factor binomials by using the difference of squares, and you will learn how to completely factor given polynomials. As you study today's tape, be sure to take careful notes. Write down all the examples, and after you have completed the tape, go back and rework them. If I place a star beside something, it probably means that you need to memorize it. Recall from our previous discussion, if one should always remove a common factor before trying other methods of factoring. The first thing you should always do in factoring is to attempt to remove a common factor. Now for today's lesson, if a binomial can be factored, it can be factored by one of the following formulas. So if you have a binomial that does not fit one of the following formulas, then it cannot be factored. In other words, if you have a binomial that doesn't fit one of the three formulas that I'm getting ready to give you, then the binomial is prime. The first formula is the formula for the difference of two squares. We have a squared minus b squared is equal to a minus b times a plus b. So notice we have the difference of two squares. To factor the difference of two squares, it is the square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. In other words, a squared minus b squared is equal to a minus b times a plus b. This would be the problem. Here is your factored form. The second formula is the difference of two cubes. We have the difference of two cubes. A cubed minus b cubed can be factored into a minus b times the square root of a squared plus ab plus b squared. Now the way I get these, the cube root of a cubed is a, so the first term is the cube root of the first term in the problem. The second term in the factor is the cube root of the second term in the problem. The cube root of b cubed is b. Now to get the trinomial, you have to remember that both signs are plus, and then you can do a times a times b times b. We also have a formula for the sum of two cubes. The sum means to add. Here we have the sum of two cubes. Notice the similarity. The two formulas are the same except for the two sign switches. Minus to plus, plus to minus. The cube root of a cubed is a, cube root of b cubed is b. Then it's a times a times b times b. For now, we will consider only case 1. In other words, in today's lesson, you are not going to have the difference of two cubes or the sum of two cubes. All of our problems will be the difference of two squares. I gave you the other two formulas so that your notes would be complete. but we will not be using them. Now let's look at some examples. Let's factor 4x squared minus 25. Well, I'm going to factor it into two parts. This is the difference of two squares. 4x squared is a square. The square root of 4x squared is 2x. 25 is a square. The square root of 25 is 5. The difference of two squares is the square root of the first minus the square root of the second, the square root of the first plus the square root of the second. Now, of course, we can check this if we want to make sure that we multiplied it correctly. So we can check it by using the FOR method. So if I multiply the first times the first, 2x times 2x is 4x squared. 2x times 5 would be a positive 10x. A negative 5 times 2x is a negative 10x. A negative 5 times a positive 5 is a negative 25. So when I combine like terms, I would get 4x squared. The 10x's cancel, minus 25. And I can see that I factored correctly. But this would be the answer when I tell you to factor it. I will not be checking the others, because if you're using the formula, you really don't need to check. The check is just to make sure you haven't made an error. Let's look at another example. 81x squared minus 16. The first thing we need to do is to make sure that both of them are perfect squares. So I need to say, what is the square root of 81x squared? In other words, what multiplied by itself gives 81x squared? Well, a little guess in checking will give us 9x. 9x times 9x is 81x squared. Well, what times itself gives 16? After a little thought, we get 4 times 4 is 16. So 81x squared minus 16 factors into 9x minus 4 times 9x plus 4. The square root of 81x squared is 9x. The square root of 16 is 4. The square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Let's look at x to the fourth minus 9. Again, we have a difference. We have two squares. If I multiply x squared times x squared, I get x to the fourth. So therefore the square root of x to the fourth is x squared. The square root of 9 is 3. So I'd have x squared minus 3, x squared plus 3.